Section 4.4 in college algebra. Lots of work today. We're going to solve equations and inequalities that are not the norm equations or inequalities. And we will do them both graphically and algebraically. On your test, you'll be asked to do it both ways. On your homework quiz, you'll be asked to do it both ways also. The reason for doing the graph is just to check to see if you did your algebra right, because the algebra can get very messy. So if we look at number 1, I already see that this is Mr. Nasty because it's got a radical involved with it. If there is a radical involved with the equation, there's also something that makes it going to be kind of nasty, is there's also x's to the non-radical stuff, right? There's x to the first power in there. Here's what we did in Algebra 2, and what we will do in this class. Get the radical all by himself on one side of the equal sign. He is, right? Isn't that a giant radical? Who cares if there's an x plus 5 underneath there? It's all under the radical, correct? How to get rid of a square root? You square it. You will square this, but the trick is you've got to square the entire right side. You can't just square each term individually. You've got to square both sides. On the left side, this is nice. The square and the square root cancel each other out, and you're left with x plus 5. On the right side, though, it's a binomial squared. That's where there's that shortcut where you square the first guy, take twice the product, or square the last guy. And if you don't remember that shortcut, don't forget, when you're squaring a binomial, you're really taking it times itself, and you got to FOIL it. So let's see if we can practice my shortcut. Square the first term, what would you get? Twice the product of these two terms. First, just figure out the product would be negative x, right? Then twice that is negative 2x. And then you square the last term, and you get plus 1, if my pen would wake up. Awesome. And now we've gotten rid of the radical. Problem now, we've got squares and first powers. It's a quadratic equation. Well, let's get it equal to 0 and factor it. X squared minus x, or minus 3x when I move that guy over here. Minus 3x minus 4. Notice when I got this equal to 0, I kept the number in front of x squared to be a positive 1 because these are easily factorable. You find two numbers that multiply together to be negative 4 and add together to be negative 3. What are those two numbers? One of them has to be negative, right? So the 4 is negative. We down with that? Factors into this. X plus 1 times x minus 4. Cool. Then we can solve for x. What would x equal? Correct. Or 4. Right? But the thing is, we don't know if those are both real solutions. They could be extraneous roots also. So we need to check them. So to check them, I will substitute them back in. If I put negative 1 in for x, wouldn't I get square root of 4 equals negative 1 minus 1? Right? You see what I did? Put negative 1 in for x into the original equation. You with me on that? What's the square root of 4? What's negative 1 minus 1? Was that an answer? Did it work? Does 2 equal negative 2? So that is not a solution to this problem. Let's see if 4 is. So I will check 4. I will say square root of 4 plus 5, which is 9, equal 4 minus 1, which is 3. I'm just substituting those back into the original equation. Y'all with me on that? Square root of 9 is 3, equal 3. Did that work? Boom. Solution 4. Negative 1 is called an extraneous answer. And that's the benefit of why we're going to graph it now also, because we will see where these things intersect. And they wouldn't have intersected in two different places. They will only intersect in one. So we go back to our original, and we will graph him. So let's go to our graphing calculator, to y equals. And I just typed each one in separately. Whatever the left side is, I typed him in as y1. And whatever the right side is, I typed him in as y2. And I know my solutions already. Right? My solution is 4. So I can probably find him on the standard window by zoom 6ing him. And I want to see what he looks like. That's the first dude that we had. That's the second dude that we had. We're looking for a sketch. So wasn't it something like this? square root guy, and then this line right here. I might have missed a little bit. That's not bad. And then here's our solution. Correct? Why is that the solution? Because that's where they're equal to each other. That's where they intersect each other at. And let's see if we can really see if that was right. If I go to second, calculate, intersect, first curve, second curve, enter, 4, 3. Did it match with my algebra? X was 4, correct? Who cares about y? But notice I didn't get x being -1 because this square root guy has a restricted domain. It would have been like in this situation if that thing would truly be a sideways parabola, but that's an extraneous answer right there. It didn't really happen. Okay, so that's why we do both. We will do the algebra because we'll get the nice and neat exact answers, because sometimes the intersection place comes out nasty, you know, and then we will do the graph. Cool. Next guy, a cube root. All right, it is a radical, but it's a cube root. Make sure he's all by himself on one side of the equal sign. How do you get rid of a cube root? You cube both sides. Then this becomes x minus -2 cubed. What is -2 cubed? -8. Awesome. X equals -7. That one was nice. Now let's make a graph of that situation. Y equals, clear that out. How do you type the cube root in is the big deal. You just take whatever the cube root thing was, which is x minus 1, put it in parentheses, and raise it to the 1/3 power, with the 1/3 being in parentheses also. That's how you do a cube root. You can do a square root by raising it to the 1/2 power. You can do a fourth root by raising it to the 1/4 power. What was the other guy? -2, is that right? And then we know our solution already is -7. That will fit on the standard window, so I will graph that. And that cube root thing, looks like a sideways snake, if you will. And scroll over. The y equals -7. Sorry, my bad. -2 is right here. That's y equals -2. And then I do my intersection, and they better intersect at the place that we found algebraically. -7, -2 was an x, -7 in our situation. Feeling good about it so far? Next. Do we have a radical? Yes. Is he by himself on one side of the equal sign? No. Get him by himself. Square root of 3x minus 2, that's the whole radical, equals x minus 2. Right? Subtract 2 from both sides. Good deal? Then, now that the radical is all by himself, we will get rid of that radical by doing whatever the reciprocal power is. This is the square root, so I will square both sides. And that would be 3x minus 2 equals, you got to square that binomial. Square the first guy, twice the product, square the last guy. And then that's a quadratic equation. So we will get him in standard form and see if we can factor him. Trying to find two numbers that multiply together to be 6, add together to be a -7. So that means that the two numbers both have to be negative. I'll bet that's -1 and -6. So that would equal x minus 1 times x minus 6, where x equals 1 or 6. We got to check them. Why do we got to check them? Because there's radicals involved. You can't take the square root of a negative number and stuff like that. They can't come out negative. So let's check 1. If I put 1 in, I get the square root of 3 minus 2 plus 2 equals 1. So if I'm checking if x equals 1, I should probably do this. Check if x equals 1, this is what you'd get. This is the square root of, my bad, square root of 1 plus 2 equals 1. Square root of 1 is 1. Add 2 to it, you get 3 equal 1. Did that work? Not going to happen. I hope 6 works. I'll check if x equals 6. Square root of 18 minus 2, which is 16. Erase this a little bit. Plus 2 equals 6. 4 plus 2 equals 6. 6 equals 6. Check. Solution 6. Make a graph of him. Graph the original, not the stuff that we changed around. So it's the square root of 3x minus 2. Then you got to close your parentheses to make sure that's the only thing underneath the radical. Then you add 2 to him. The other guy is x. And then we know our solution is 6, so it'll be on the standard window when we graph him. Here's my square root guy. There's my line. So I'll make that rough sketch. Square root guy looks something like this. The line was y equals x, which looked like that. And then where they intersect, you can calculate that, where they intersect. It's just like my height, baby. 6'6". Fun stuff. We okay with what I'm doing, though, right? Makes sense? Nice. This one, not so nice. These are the ones we struggled with in Algebra 2. Radical involved? You bet. More than one radical involved. Oh, no. Get a radical all by himself on one side of the equal sign. Usually the messy one. Wouldn't you call him the messier radical compared to that radical right there? He is all alone. So what we do is we will square both sides. This whole quantity right meow has to get squared. This whole thing right here has to get squared. So far, so good. This is a binomial. There are two different terms. This is not a binomial because remember a radical is a grouping symbol, right? There's just one junk underneath that radical. This guy, you got x, then you've got a whole other term right here. So we got to do the trick. Let's square the first guy. What's the square root of x squared? Turn out to be x. Then I need twice the product of these two terms. Well, the product of those would be negative square root of x. You with me on that? I need twice that. What would twice that be? Negative 2 square roots of x would be twice that, right? Because you're just taking it times the negative 1 in front. So you get negative 2 square roots of x when you take twice the product of those. Does that make sense? That's the hardest part about that. People are like, I don't get where that part comes from. Like if I did this, 3 square roots of 2 times 2, right? I want twice 3 square roots of 2. You take number times number, right, and you get 6, and then the radical just comes along for the ride. I'm taking negative square root of x, which is negative 1 square root of x, times 2, number times number, and the radical comes along for the ride. So just negative 2 square roots of x. Square the last guy, you get 1. This guy, he is easy because that's just one term right there. When you square the square root of x minus 5, you get x minus 5. We're down with that. So far, what we did with that stage is we eliminated one of those radicals. There are still another radical in this equation. So now our job is to take this brother and get the other radical all by himself. So let me get rid of this for a second. I need to get this, well really I should say, sorry, this all by himself on one side of the equal sign. Again, get the radical all by himself. Well, wouldn't I subtract x over, right? So when I do that, what's x minus x? There, nothing. Wouldn't I also subtract this 1 over, right? So those are gone. Negative 2 square roots of x comes down, and you get negative 6. With me so far? To get the radical all by himself, wouldn't you get rid of this times negative 2 by dividing both sides by negative 2? So that would be square root of x equals 3, right? Now the radical is all by himself again. To get rid of that radical, I will not square root. What will I do to get rid of that radical? I will square both sides. X equals 9. It's not a plus or minus situation. You didn't square root anything. You just squared stuff, right? So x will equal 9. We got rid of one radical by squaring this bad boy. In the process, though, there was still another radical. So to do this, start over, right? Get that radical by himself and get rid of him. X equals 9. Let's check to see if it actually worked. Square root of 9 is 3 minus 1 equals the square root of 9 minus 5, which is 4, right? 3 minus 1 is 2, and the square root of 4 is 2. He checked, right? So that was good. Now let's graph them both. It's going to be kind of funny looking. Clear, clear. Second square root of x. Close those parentheses. Then throw the minus 1 on there. And then the square root of x minus 5. All of that stuff goes underneath the radical, so it's all in parentheses. And it'll look like two little square root function guys, those half sideways parabolas. We know it fits on the standard window because they intersect at 9. So let's see what it looks like, though. Kind of weird. You got one going here, and then you got another one. Let me see what it looks like again. And then you got another one starting 5 units over. Something of the sorts of this. Yeah. They intersect right there. And then you can find that intersection place with your calculator. It was at 9 what? 2. Cool. Those are the messiest ones that we'll have, right? The double radicals is kind of what people like to call them. It's like, well, you got like more than one radical. Get rid of one of them because this guy's one term, this is 2 terms over here. We'll be in good shape. Don't have a radical, but you got a rational exponent. Get the rational exponent term all by himself on one side of the equal sign. But what I need to do first, add 4. Oops. This thing right here really says the cube root of x minus 3 squared. Remember, power over root? Like this is really a cube root situation. Well, how do you get rid of the 2/3 power? Raise both sides to the reciprocal power. So I'm going to raise both sides to the 3/2 power. Because when you take a power to a power, you should multiply those exponents. And last I checked, 2/3 times 3/2 will multiply to be 1. Right? That's why they cancel each other out. You're left with x minus 3. 4 to the 2/3 power. Let's see if we can remember some cool tricks. It's power over root instead of just typing it in. This is a second root, a.k.a. the square root. Do you know the square root of 4? It is 2. Then take that to the 3rd power. 2 to the 3rd power is 8. Again, that's power over root, so you did the second root of 4, which is 2. Then you took it to the 3rd power. Again, punch it in the calculator too. I mean, it would work, you know. Then you add 3 to both sides, and x equals 11. Check him. If we put 11 in, you'd get 8 to the 2/3 power. 8 to the 2/3 power minus 4 equals 0. 3rd root of 8, a.k.a. the cube root of 8. What's the cube root of 8? 2 squared, which is 4, and 4 minus 4 is 0. So 0 equals 0. It checked. And then we'll sketch him. Type that in. Come on, man. Clear all this junk out. Just put all that stuff in parentheses. X minus 3 raised to that 2 divided by 3 power. Then just hit minus 4. And then this guy hit 0. And then it's not going to fit on the standard window. Then I graph it. Looks really weird. Like a birdie. Like if you was to sketch a bird. That's a bird. So, looks something like this. You want to know where it didn't look like that at all. Where did it move over? What did I do wrong? How many answers did we get? We want to know where it equals 0. Shouldn't it be in 2 different places? Where did I make my mistake? Yep, when you do the square root of 4, what's the square root of 4? Plus or minus 2, right? So you could have plus or minus 2 here. So let me make this in a big window again. I messed up. All right, I got too excited. So let's get back to this stage, right? When you do the square root of 4, you could get plus or minus 2, right? So plus or minus 2. Then you got to cube it. If you cube 2, you would get 8. Or if you cubed negative 2, you would get negative 8. So you'd have x minus 3 equals 8, or x minus 3 equals negative 8. My bad. Because we had an even root, you'll get a plus or minus situation when you square root. So you had to set up 2 different scenarios. You would get your plus or minus 2, and then it would have to get cubed, so you'd have your plus or minus 8 in that situation. So this guy still x equals 11. This guy x equals negative 5, right? And that is the benefit of why we graph it, because even an awesome person like me just made a baby mistake like that. It's like, wait a minute. My little birdie, if you will, which doesn't look like that at all, erase. It intersected over here and over here. This is at 11, 0, and this is at negative 5, 0. You cool with that? So that's how I knew it should have 2 answers. That's why I'm making the sketch. Woo! Fun. Quadratics. And is it an equation anymore, or is it an inequality? Inequality. If you have a quadratic inequality, we will do this move every time. We will get it to be 0. It's not equal to 0, but we will make this greater than 0 or less than 0, depending on what that symbol is. So move everything over. Keep the x squared positive, and let's get this puppy in standard form. So I need to add 5x over and subtract 3 over. And my symbol did not change because I didn't multiply or divide by a negative number. But we want that bad boy in standard form. Let's see if he can factor. Does he factor? 2 numbers multiplying negative 3 had the other be positive 2. Can we find those? 1 and 3, and if the 1 was negative, does that work? So x minus 1, x plus 3 greater than 0. Cool. Then what we'll do is we'll find our roots. Our roots are where this thing crosses the x-axis at. That's what we've been doing your whole math life. When you factor and when you solve a quadratic, when you solve for x, you are finding the roots. You are finding the x-intercepts. X could equal 1 or negative 3, right? That means that this parabola crosses the x-axis at 1 and at negative 3. So let's put those on my sketch at 1 and at negative 3. I don't even care about the y values. I know what they are. They're 0. That's what we just figured out. Look back to this guy right here. He is a parabola. You know if he opens up or opens down. So let's make that awesome rough sketch. It's a parabola that opens up, and they have to go through those 2 roots. So far, so good. This was not an equation, no, it was an inequality. They want to know where this thing is greater than 0. Well, that's when the y values are greater than 0. Would that be above the x-axis or below the x-axis? So what we did in Algebra 2 was we made a little shade. We said, here's our answers. Everything on this part of the parabola is our answers. And now they want that, if we go back and read the original instructions, they want that in both interval notation and set notation for domain. So let's start with interval notation. Where are the green squiggles if I read from left to right? Far left I could go is negative infinity. Would the green squiggles be touching this thing if I went there? Yes or no? Yes. All the way up to right here is where the green squiggles would be, correct? So from negative infinity, from all the way down here to negative 3, The question is, does negative 3 included or not included? Read this symbol. Is it included or not included? Not included. Then, if I was still working from left to right, all of a sudden it's not touching the green squiggle. It's not touching, because down here it's negative, right? It's not greater than 0. So it starts back over again at 1, which again is not included because there was no equal to bar here, and it goes to infinity. You cool with that? Make the quadratic in standard form, factor him, find your roots, that's where it crosses the x-axis at, then read, is it supposed to be greater than 0 or less than 0, and put some squiggles. Let's try another one. This is a quadratic, correct? And it's an inequality. Yes? Oh, thank you. We're supposed to do both notations. My bad. How many answers are there? 2 or 1? How many different intervals are there? 2 or 1? 2. So what we do is we do it in set notation also. So it's the set of all x's such that. I just need to interpret this. What does that mean? That means that x is less than negative 3. Right? Aren't all those numbers less than negative 3 from negative infinity to negative 3 not included? Union means or. And then what does this mean right here? X is what? Greater than 1. I'm glad you said that because Math Excel wants it in both forms. Okay? We cool with that? Boom. That's a quadratic. It's an inequality. Needed to be in standard form. It is in standard form. This is very easily factorable. It's none of that two numbers that multiply together to be C and add together to be B stuff. Is there something common between both of those guys? It is a perfect square, right? This is a perfect square, that's a perfect square. Is it a difference of squares, though? Not a difference of squares, because that's a plus sign. But does this have some x's in it? Does this have some x's in it? 3 letters, GCF. What can we take out for a GCF? X. X is common to every term over there. Couldn't do that back here. You look at this guy. This has some x's in it, that has some x's in it, but that does not have x's in it, right? You can't pull out a GCF of x. Because there's only 2 terms in this guy, we look for 2 possible scenarios. If there's a GCF that can come out, or if it's a difference of squares. And you do GCF first. And there is a GCF of x. So doesn't this become x plus 4 less than 0? Solve for x. Let's find our roots. Because now this is a linear guy times a linear guy. What would make him turn out to be 0 if that was actually how much? 0? Or how about this guy right here? What would make him turn out to be 0 if x was? Negative 4. There's our x-intercepts right there. Plot them. 0, 0, negative 4, 0. Look back to the original problem. It's a parabola. Which way would he open? Up or down? Up. So sketch him open it up. Then with your pencil, we're going to put some squiggles of where this satisfies the inequality at. They want it less than 0, so wouldn't that be all of this stuff right here? Isn't that where it's less than 0? Right? So let's put that in set interval notation first. The domain would be, well, it's just this interval from negative 4. Does it count or not count? Not count to 0. And that also does not count. Rock and roll? And then when you do the set notation, it's a set of all x such that, since it's only one cool little interval, that's where you put that compound inequality where x is in the middle. The symbols always point to the left. You decide if they need equal bars or not. These do not need equal bars. The smaller number in your boundary goes on the left, which was negative 4. The bigger number in your boundary goes to the right. That says all the x's got to be greater than negative 4 and at the same time less than 0. Yeah. This guy, quadratic again, inequality again, put them in standard form again. Whoops, not equals though, greater than 0, greater than or equal to 0. 2, 8, 24, 2, 8, 24, 2, 8, 24, what can we do? GCF of 2. here. Factored out a 2, right? He doesn't even matter anymore, really. We're just looking at him. That's easily factorable because the a value is 1. See if it can actually factor, though. Some of these, they might not factor. You might have to do the quadratic formula on them, you know. Two numbers multiplied together would be negative 12. Add together would be negative 4. So 2 and 6, but the 6 has to be negative, right? So x a plus 2 times a x a minus 6 greater than or equal to 0. My roots, x could be negative 2 or 6. Plot them on the x-axis, negative 2, 0, 6, 0. Go back to your original problem, the one that you got in standard form right here. It doesn't necessarily have to be the original, but the one right here in green where we got it equal to 0. Open up or open down. Where's squiggles go? Well, it's got to be greater than or equal to 0. So that's above the x-axis. These are the numbers on the y values that are bigger than 0. All right, y is 1, 2, 3, 4, 5. They're bigger than 0 up here. Domain from negative infinity all the way over to negative 2. The question is, does negative 2 count this time? Yes or no? Yes. Equal to bar, right? Equal to bar, so he counts. Union, start over again at 6, which does count to infinity. Two different interval ranges, meaning that's an OR statement. So the set of all x is such that this guy really means x is less than or equal to negative 2, or x is greater than or equal to 6 in set notation. If there's one interval, that's where you do the little compound inequality. If there's two intervals, write them separately, throw an OR in the middle. Maybe they'll make you put a union symbol on My Math Lab, I don't know. Yeah, not a quadratic anymore. Absolute value. For those of you who had me in the past, you'll remember absolute value inequalities. There is a phrase, disunion greater than or. You might want to write that down if you've never had me before. It tells you right away, once you've got the bars by themselves, if this is going to be an and or an or statement when you're all said and done. The dis stood for disjunction, because there's also conjunctions. Union means it's going to be a union. Greater than, if it had a greater than symbol, or means it's going to be an or. All of these things go together. Let me try that again. Isolate the bars. Are the bars by themselves? Yes. Then you read this, disunion greater than or. Is this symbol a greater than symbol? Yes or no? Since it's not a greater than symbol, this will not be a disjunction. It will not be a union. It will not be an or statement. It will be the complete opposite of that, which is a conjunction, which is an intersection, which is a less than scenario, which is the word and. Disunion greater than or, I kind of told my Algebra 2 students, it's like saying this union is greater than yours, meaning this country is better than yours, because you're talking to all the foreigners around you, right? It's like this union greater than or. If it's a greater than symbol, you'll have an or statement. If it's a less than symbol, you'll have an and statement, is what it all boils down to. So we set up two scenarios because there's absolute value involved. 2x minus 3 will be less than or equal to 5. I just kind of dropped the bars, and what I saw was what I got. All right, absolute value of this, less than or equal to 5. Then I throw the word in the middle. The word in this case is and. Not an or statement. This is an and statement. When you have absolute value and a less than, that's going to be an and statement. Then you take what's in the bars again, and you switch the symbol, switch the sign. This symbol became switched, and this 5 became switched also. Solve them both. Don't forget, sometimes you got to switch that symbol when you multiply or divide by a negative. Bring the word down also. Cool. I can go straight into my notations. First I'll do set notation because that's what this stuff's all about. And statements are always the compound inequalities. So it's a set of all x such that, that's the one where x is in the middle. The symbols always point to the left. These guys have equal to bars this time. Then the smaller of these two numbers goes on the left. Pretty sure that's -1, right? That goes on the left. The bigger guy goes on the right. In interval notation, the domain would be from -1 to 4 included both times. Then you'd graph both guys to double check yourself. So the first guy I'll graph will be the absolute value of x minus 5. There's a couple ways to get to absolute value. The fastest way to get to absolute value is if you go to second, and right above your 0 key, it's called your catalog. The catalog lists every function that your calculator can possibly do, and absolute value is the first one in alphabetical order. So second absolute value of 2x minus 3. Some of your calculators put the bars already. Some of them have to be in parentheses. Depends on your calculator. This guy's 5. Graph it, and you'll see that picture. So the absolute value guy look like this. The 5, y equals 5, looks like this. And that's where they intersected. At -1, 5, and 4, 5. Woo! I like algebra. Next, absolute value inequality. I use the phrase this union greater than or to help me, but the bars must be by themselves first. Are the bars all by themselves on one side of the symbol? If they weren't, you'd have to isolate them. Like if there was a times 2 in front of here, then you'd have to divide both sides by 2 first, right? If there was a plus 3 outside the bars, you'd have to subtract 3 from both sides. So, boom, this union greater than ors. Is this a greater than symbol? What that tells you is the word we need is or. This union greater than or. So, we will set up two scenarios. What's in the bars? What you see is what you get. The word I need in this case is or because of the greater than symbol. Then again, you take what's in the bars and you switch the symbol, switch the sign. Since it was a greater than, it becomes a less than. And then since it was a positive 2, it becomes -2. And you solve both scenarios. Sweet. If you have some purple note card graph translation theorem knowledge, you can sketch this really easily, but you should use your calculator to see if they intersect in those places in the first place. But this is the absolute value v that shifted 6 units right. This is y equals 2. I know what they look like already because I got translated 6 units right. So you can check your sketch, make sure those are the right two answers at 4-2 and at 8-2 on your sketch. Then we got to put them in notation. Set notation's already done for us. Set of all x such that, since there was an or statement, that's a disjunction. There's just two different answers. You copy what you had right down in there. X could be greater than or equal to 8 or x less than or equal to 4. And then that's where the sketch could help you again if you wanted to. You go back to your original. Here's your sketch. You want to know when it was greater than 2. So that's all of this stuff up here if you like the squiggle idea. And you could do your interval notation. That was the domain is from -infinity to 4. And it is included, my bad, because of the equal to bar, union 8 to infinity. That's why it's called this union greater than or. It is a disjunction, which means there are two pieces or more than one piece, It is a union situation when you put it in interval notation. It was a greater than symbol in the first place when we started, and it was an or statement when you put it in set notation. Disjunction, union, greater than, or. Yeah, haha. What's this one? Same idea again. Let's go to 12. The revenue of this, boy, I bet you're getting used to these cost, revenue, and profit situations. See if you can write me a profit equation. Read that and write a profit equation. Profit equals what again? Revenue minus cost. Profit equals revenue minus cost. So profit will equal 200x minus 0.01x squared minus the cost. So all the signs will change when you subtract it away. Because you're subtracting away the cost function. So it's the green one minus the blue one. And then we got to combine like terms on that profit equation. That's 0.02x squared. And how many x's is that? 200x minus 38x is how many x's? 162x minus 16,000. Y'all cool with getting the equation? We've done that probably about 12, 15 times now. Profit. Revenue minus cost. So what do they want to know? It says producing and selling how many units will result in a profit. Well, let me think about this. First I'll make a rough sketch for you, then we'll use our calculator to sketch it. This guy, what shape does he make? Parabola. Which way does it open? Up or down? Down. Take a wild guess what the y-intercept is. Not 16,000, but negative 16,000. So just a rough sketch. Don't draw this yet. It starts right here, and then it does this. And then doesn't it open down? Correct? Why, oh why, is the y-intercept negative in this situation? What happens when you start any kind of company and it's talking about profit? If you wanted to sell shoes, what would you really have to do before you could sell a bunch of shoes? You'd have to buy some shoes or make some shoes. Wouldn't it cost you money to make all the shoes? Don't they start out $16,000 in the hole because whatever they're selling, it cost them some stuff. And at that time, they have made no revenue because they haven't sold anything. So their revenue was zero minus their cost, which was $16,000, resulted in a negative $16,000 profit. What happens right here? What happens right there? What's the y value? Remember, we're all about y right here. What's the y value in that ordered pair? 0. How much profit have they made right here? Nothing. Break-even point, correct? What happens here? What's the y value? Positive, negative, or 0? Positive. And then is it still positive where I'm squiggling? Even though they're not making as much money, isn't it still positive, correct? What happens right here again? 0. Because whatever shoes you're making or whatever, they're cool at first, then everybody has them, and then sales drop off, and all of a sudden, if you kept making those shoes and nobody wants to buy them, wouldn't you start losing money again, right? That's what happens. You in the hole, all right, I sold enough shoes to break even, now we're really making some money. Oh crap, nobody likes my shoes anymore, nobody likes my shoes anymore. I'm still making some money, but I should probably stop making the shoes right about here, or really right there is when you should stop making the shoes, because isn't that where you reach your maximum profit at, correct? So they're asking us, where would this give us a profit? How about the red squiggled zone? Is profit in the red squiggled zone? Did we make money where I red squiggled? So let's use our calculator to figure out where that is. I will type this quadratic equation in. Negative 0.02 x squared plus 162x minus 16,000. Now, before we even dare try to graph this, I got a little ahead of myself. You spend too much time trying to find a window. Let's go back to our paper. Let's find the vertex of this parabola. How do you find the x value of the vertex? Opposite of b over 2 times a. Negative 162 over 2 times a, negative 0.04. Punch that in for me for a second. I don't know. What is that? 1,000? 4,000. Thank you. What does that tell me? That tells me, boom, this x value is 4,000. That tells you on your x-axis scale, was that right, 4,000? What? 4,050. Okay. Sorry. Way ahead of myself. 4,000 would have been fine, though, because if you zoom 6 this thing, that's 10 to 10. Would you see anything? No way. When you find the x value of the vertex, that tells me, hey, man, here's the line of symmetry in this thing, and that's 4,050. Take a wild guess where that's going to be. Probably in the 6,000 to 8,000 range. You know what I mean? So on my window, I know my x-axis scale probably better go up to, I'm just going to be safe, and go to 10,000 by probably thousands. Cool? Y-axis scale. I already know I'm $16,000 in the hole, right? I could go ahead and find the y value of my vertex by substituting that in, if you want to. Put that in for x and find the y value, but why don't we just take a wild guess and see what happens? Let's say 50,000. I don't know. I'm just guessing. Why 50,000? Because I know down here is negative 16,000, and who knows? I'll go by 10,000. And then I'll graph it. I didn't get to see the vertex, did I? First, did I type it in right? Negative 0.02x squared plus 162x minus 16,000, right? That's right? Okay. There's my graph. I didn't get to see the vertex. Do I care about the vertex? They're asking me where the red squiggle is. What you care about is these 2 points, correct? So what else could I graph on my graphing calculator to help me find those really easy? Y equals 0. Graph y equals 0. And then you could calculate where those 2 things intersect. You won't see it because it's the x-axis again. That's what y equals 0 is. So calculate the intersection, first curve, second curve, and guess it'll find one of them. Boom. 8,000, 0 was one of them. Find me the other one. So second, calculate 5, first curve, second curve. Here's the easier way to move your cursor. When you guess, make sure this guy says y2. You don't want it to be on the first guy. Like if you hit up or down, you don't want your cursor to be on the first equation, which is that parabola. It would take forever to get this cursor to get all the way over there. If it's on y equals 0, it just slides right over there. So it's got to be closer to it. And where was it at? 100? And that's right, my thing freaked out because I hit it too many times. Keep going and going and going and going and going. 100, 0. That's why you don't hit it too many times, because it just doesn't stop. So in interval notation, like we got to interpret this. How many units would they have to produce in order to make a profit? If they were at 100, 0, they wouldn't make a profit. When they made 100 pairs of shoes, or whatever the heck we're talking about, they broke even. What would they have to do? Make how much? More than 100 pairs of shoes, but at the same time, less than 8,000. So the set of all x such that the number of shoes they make, I do not eat equal to bars, is bigger than 100, but less than 8,000 pairs of shoes. Does that one make sense to you? With the sketch and the profit and all of that stuff?